All right, so we're looking at the 3.7b guided notes. Again, I miss another typo. I have it as 3.6b. That's my fault, and I apologize for that. So let's just write on top compound inequalities. There are two types. We have the and compound inequality. So we have the and then we have the or compound inequality. The and compound inequality, that's the one where we have a number less than our variable less than a number. For the or compound inequality, we have x is less than a number, or x is greater than a number. Notice here we have or is written right in between, right? So these are the two compound inequalities. One we could solve together. The other one we have to solve separately. So let's take a look at what this says. The key idea here is that we're going to solve the absolute value inequalities, and we're going to isolate the absolute value values first. That has to be the very first thing we do. Next, we break it up to see if it is break it up according to whether or not it's greater or less than. Now, I misspelled these words on purpose because less than will go here. Here's when we have the less than. So all of our absolute values that are less than, we're going to create and compound inequalities. The ones that are greater than, we're going to say they are greater. Okay? And so we're going to break them up, and then we solve normally and graph on a number line. So let's take a look at the first one. The first one says the absolute value of x is less than 7. So less than, this is the less than, right? The less than. So that's the one we need to break up into this guy here. That's the and, less than. So we need to have a number here less than x, which is less than the other number. Here we have 7. So we're going to break this into negative 7 less than x less than 7. And graphing that on a number line, we get here's 7, got a 0, got a negative 7. It's going to be open. All right, these are going to be open, and we'll shade in between. All right, this one, the absolute value of 3x minus 2, the absolute value of this, it's already isolated. There's nothing I need to do here for part 1. So step 2, it's greater. So it's greater, meaning I need a 3x minus 2 greater than or equal to 13, or 3x minus 2 is less than or equal to negative 13. So here's my or statement, my big or statement right here. So now this we could solve normally. Here we're going to add 2 to both sides. I'm going to get 3x is greater than or equal to 15. And divide by 3. So x is greater than or equal to 5. And now here I got to add 2 to both sides, plus 2. So I get 3x is less than or equal to negative 11. And then we divide by 3. So x is less than or equal to negative 11 thirds. Now we can graph that on a number line here. And get negative 11 thirds over here. 0. Here's 5. And we're going to have an close. It's going to be closed at 5. It's going to be closed at negative 11. Alright, so x is bigger than 5, so we're going to shade to the right. X is smaller than negative 11, so we're shading to the left. Not too bad, not too bad. Okay, so here, we need to pay attention to this guy. When solving these inequalities, we have to isolate the absolute value bars first. So I want to get those by themselves first. So we take 5 away from both sides. And get the absolute value of x minus 1 is greater than 12. Well, good. So this is the greater, meaning I have to split it into x minus 1 is greater than 12, so I stay with the one that I see. X minus 1 is bigger than 12. Or x minus 1 is less than negative 12. And I can add 1 to all the sides. I get x is greater than 13. I add 1 to both sides here. And x is less than negative 11. And now we could graph on our number line. It's a big arrow. And we have an arrow here. Alright, so I have a 0. I have 13 over here. I have negative 11 over here. So I have open circles at negative 11 and open circle at 13. X is bigger than 13, so that's going to the right. X is smaller than negative 11, so that's going to the left. Okay, here. I need to isolate my absolute value bars first. So I subtract 7 from both sides, minus 7. So I get 2 times the absolute value of x minus 4 is less than or equal to negative 4. And divide by 2. So I get the absolute value of x minus 4 is less than or equal to negative 2. Now again, absolute value is always positive. But if we think about this in terms of distance, my distance away from 0 is less than a negative number. Well, that's impossible. So this has no solution. Here, if it's less than a negative number, there will never be a solution. So if my absolute value is less than or equal to or strictly less than some sort of a negative number, there will never be a solution to that. Okay, for this one here, this one was complicated. Well, let's isolate the absolute value bar, the absolute value bars first. So I'm going to take 12 away, minus 12, and I get the absolute value of 4x minus 7 thirds is greater than, let's see, what is that, negative 9? So here it's saying my distance away from 0 on a number line is bigger than negative 9. Well, distance is always positive, and all the positive numbers in the world are bigger than negative 9. So here I have all real numbers. Okay, let's try this last one out. The absolute value of x minus 1 divided by 5 minus 3 is less than or equal to negative 1. So we got to isolate those absolute values. Have to isolate the absolute value bars first. So I add 3 to both sides, and I get the absolute value of x minus 1 over 5 is less than or equal to 2. Multiply both sides by 5 over 1. Cancels here. Multiply that by 5, and I get the absolute value of x minus 1 is less than or equal to 10. So here it's less than, right? Less than. So I'm going to break this here where I have the negative number and x in between the negative and the positive version. So here I get negative 10 is less than or equal to x minus 1 less than or equal to 10. And I add 1 to all sides plus 1 to all sides. And I get negative 9 is less than or equal to x, which is less than or equal to 11. And that we can graph on a number line. Here we go, here and here. So we get negative 9, have some 0, and 11. Close circles on both. And shading in between.
There will be a girls' basketball meeting today in room 212 at 3:05. Girls' basketball meeting today in room 212 at 3:05. Chris Gavero, please come to the front office. Chris Gavero, please come to the front office.
Okay, so we want to be very careful here. So we're on page 211 again. I want to do problems 32 through 46 even. And then I want to do 49 through 60. So is that 12 problems? Yeah, we can do all those. Alright. And I'll see you in class. Now be careful with this chunk here. There's some equalities and inequalities, so be very, very careful.